I went out of order. So this is chapter 6, day 3, special right triangles. But now we're going to do the 30, 60, 90. And again, I just kind of prefer doing the 45s first. I think they're easier. Once you get an idea of kind of what it is you're talking about, then from there it's sort of the jump to 30, 60 I don't think is as big. So Darren wants to determine the side lengths of the triangle at right. Unfortunately, he left his calculator at home and he does not remember the value of the cosine of 60 degrees. So if you guys remember, we started this thing by saying, I don't know if this is still it. Shoot. Let me pause real quick. 6 videos by saying people noticed that the sine and cosine of 60 degrees were the opposite of the sine and cosine for 30 degrees. And in particular, the 0.5, which is a half, made them very easy to work with, right? So like 61 and 29 are also opposites, but they're not 0.5, so they're not as easy to do. So the fact that they're the opposite but 0.5 as well made them a lot easier to deal with. So if we look here, it says Darren wants to determine the side lengths of the triangle at right. Unfortunately, he left his calculator at home and does not remember the value of the cosine of 60. That's okay, says his teammate. I think I see a way to figure it out. Using tracing paper, she creates a diagram at right by reflecting the triangle across B. What's the resulting shape? Well, what we should know is that this is 60 degrees and this is 60 degrees and this is 230 degrees, right? So what we're looking at is an equilateral triangle again. So this is 60, this is 30, and this is 30, and 30 plus 30 is 60. So that means all the side lengths must equal 2, right? Because it's an equilateral triangle. So it says, what if Jan had reflected across a different side? Would the result still be an equilateral triangle? I don't know. If she went over here, it looks like we'd be getting a rectangle of some sort. So it says, use Jan's diagram to determine the side length of A. Well, think about it. It's half of 2. So A must be 1. And it says, now determine the side length of B. So what we're looking at is we have a triangle that looks like this. So we can say 1 squared plus b squared equals 2 squared. So 1 plus b squared is equal to 4. Let me go ahead and create a little room right here. So if I keep going with this, I will subtract 1 from each side. B squared is equal to 3. I will square root each side. And b will equal the square root of 3. So that means our right triangle will look like this. And again, this was the 60 degree angle, this was the 30 degree angle, and this hypotenuse equal 2. So we determined that the 30 degree angle was 1, and the 60 degree angle was the square root of 3, which is probably my funniest math joke, and I know I have a lot of funny math jokes, but this is my funniest. Doing 30, 60, 90 triangles is as easy as 1, 2, square root of 3. Isn't that clever? Because people say it's as easy as 1, 2, 3. But in this, you say it's as easy as 1, 2, square root of 3. So funny. All right, so if we look back over at our graphic organizer, you'll notice we have 3 boxes for 30, 60, 90 triangles, right? They're all 30, 60, 90 triangles. And the reason that we have 3 separate boxes is because sometimes they might give us the 30 degree side, and we need to solve for the 60 degree side and the hypotenuse. Sometimes they might give us the hypotenuse, and we need to solve for the 2 legs. And sometimes they might give us the 60 degree side, and we need to solve for the 30 degree side and the hypotenuse. So different ones each time. And again, if we keep referring back to this, I think it's going to be a lot easier to sort of deal with. So if I look here, I know this is a 30, 60, 90. And they are given the 30 degree side, and we need to solve for the other. So solve for 60 degree side and hypotenuse. Actually, maybe I should have went out of order here. Let me change my mind on this. Instead, we're going to solve for the hypotenuse and the 60 degree side, because I guess it doesn't really matter. There's some of these sides, because it's that 1 to 2 ratio, I think the hypotenuse is usually easier to start with. So we'll call that the 60 degree leg. So if I want the hypotenuse, So again, if we're given the 30 degree side, the hypotenuse, we just double it. So we're going to, yeah, how do I want to say this? The hypotenuse, we'll just say multiply 30 degree leg by 2. So in this example, we're going to get a hypotenuse of 4. To get the 60 degree leg, we're going to multiply the 30 degree leg by the square root of 3. So the 60 degree side is going to equal 2 times the square root of 3. So if I go back over to this triangle, I know that this must equal 4, and I know that this must equal 2 times the square root of 3. Well, that makes a lot of sense because 2 squared plus 2 times the square root of 3 squared is going to equal 4 squared. 2 squared is 4, plus, again, think about this. 2 times 2 is 4, and square root of 3 times the square root of 3 is 3, so 4 times 3 is 12, and then 4 squared is 16. So you can see that worked out great. So these are our rules if we start with given the 30 degree side, leg. Actually, I should change this to leg. I think that's better as leg right there, honestly. Sorry, I'm kind of riffing here, and it's not going great. All right, so now, what if we're given the hypotenuse? So I know this is a 30, 60, 90 triangle. And on this one, we are given the hypotenuse. And we need to solve for the 30 degree leg and the 60 degree leg. And on this one, again, you can do it different ways, but there's a couple different ways to do this. So my preferred way is first I solve for the 30 degree leg. And I do that by, I take the hypotenuse, I divide the hypotenuse by 2. So in this example, we're going to say 16 divided by 2 equals 8. So I know that this is my 30 degree side, right? This is 60, this is 30. This must equal 8. And then from there, to solve for the 60 degree leg, I'm just going to multiply the 30 degree leg by the square root of 3, right? And that's going to be, I think, by a mile the easiest way to do it. So I will get 8 times the square root of 3 for the 60 degree leg. Now, again, if you don't believe me, it's just going to be 8 times the square root of 3 squared plus 8 squared is equal to 16 squared. This is going to be 64, right? 8 times 8 is 64. Square root of 3 times square root of 3 is 3. So I'll grab my calculator, 64 times 3. This is going to equal 192 plus 64 is going to equal 16 squared, which I'm guessing will equal 256, right? 192 plus 64 is 256. So let's see if 16 squared equals 256. And it does. So there we go. So that works. I think this is the easiest way to do it. But if you want to solve for the 60, this is the alternate one. If you want to solve for the 60 degree leg first, you're really going to need to sort of recognize that you're dividing by the square root of, no, you're not dividing by the square root of 3. I don't even know what the relationship is between the 60 degree side and the 30 degree side, quite frankly. Yeah, I would just say let's not do it this way. Let's just do it this way. First, we'll get the 30 degree leg, and then we'll use that to get the 60 degree leg. It's just going to be so much easier than trying to go straight from here to here and then back to here. All right, so what happens if we are given the 60 degree leg first? So we got another 30, 60, 90. Well, I think the easiest thing to do, so we're given the 60-degree leg first, and we need to solve, and in order, I would solve for the 30-degree leg first, and then the hypotenuse. And again, I think order is pretty important on these. It makes it go a lot more smoothly. So the first thing I'm going to do, and now I kind of regret not using this space over here. I wish I'd used more space, so I apologize. So the first thing I'm going to do is I'm going to solve for the yeah, I'm sorry, I'm a little bit, I see what I was doing. I was a little bit messed up on that one. Okay, so the first thing I'm going to do is solve for the 30-degree leg. And to do that, I'm going to divide the 60-degree leg by the square root of 3, right? So what I will do is I will take 12 and divide it by the square root of 3. Uh-oh, my phone call. My phone is loud. So anyways, I have to rationalize this denominator. I will get 12 times the square root of 3 over 3. Now I can simplify the 12 and the 3, right? And I will get 4 times the square root of 3. So I know that my 30-degree side is going to be 4 times the square root of 3. And now that I have that, what I'll do is I will take the 30-degree side and get the hypotenuse. So I will solve the hypotenuse I will multiply the 30-degree leg by 2. So on this one, 4 times the square root of 3 times 2 is going to equal 8 times the square root of 3. And that will be my hypotenuse. And that doesn't make any good sense at all. So 1, 2, square root of 3. Oh wait, yeah, that does make sense, actually. Never mind. I'm just looking, I know the hypotenuse needs to be the biggest number, and I'm seeing 8 is smaller than 12 and thinking I did something wrong, but this is an 8. This is 8 times the square root of 3, which is going to be more than 12. Alright, so long story short, 4 times the square root of 3 squared, this leg squared, plus this leg squared, should equal this hypotenuse squared. So let's see if it does. I know that 4 times 4 is 16. I know the square root of 3 times square root of 3 is 3. So 16 times 3 is 48. I know that 12 times 12 is 144. And so what I'm hoping is that the 8 times the square root of 3 squared will equal these two added together. Well, think about it. 8 times 8 is 64. Times the square root of 3 times the square root of 3 is 3. So I am guessing that when I add these together, I get 192. I'm assuming that 64 times 3 will equal 192. And it does. So that does check out. So a lot of work, like kind of a pain, right? But not too bad if we have this thing. And now what I'll do is I will pause this and set up the rest of the video where I show that we can use these sort of relationships, especially if we go in order, to make these not so bad. So let me pause and we'll see where we're at. You'll notice on this one, we have to solve for x and y. They gave me the 30 degrees angle, right? So I'm going to come over here, and again, I think this becomes pretty useful. We're given the 30-degree leg, so we can solve for the hypotenuse and so the hypotenuse, we're just going to double the 30-degree leg. So I'm going to go over here. I'm going to double the 30-degree leg. 8 doubled equals 16. That'll be the hypotenuse. In order to get the 60-degree leg, I'm going to multiply the 30-degree leg by the square root of 3. So I'm going to say 8 times the square root of 3. And again, if you do the math there, 8 times the square root of 3 squared plus 8 squared, you will get 16 squared. So not the worst thing in the world. What happens if they give us the 60-degree side? All right, so we've already done an example with the 30-degree side, so let's look at the 60-degree side. So I'm going to go over here, and I'm going to look at the one where they give us a 60 degree. There's the hypotenuse. So if they give us a 60-degree leg, we said the first thing we're going to do is solve for the 30-degree leg by dividing by the square root of 3. So I'll come over here, and I'm going to divide 12 by the square root of 3. And I can't have an irrational denominator, so I'll multiply by 1 in the form of the square root of 3 over the square root of 3. I get 12 times the square root of 3 over 3. These are going to simplify. They give me 4 times the square root of 3. So I know that my 30-degree side is going to be 4 times the square root of 3. And again, if you're not sure if that's right, think about it. If I wanted to go from the 30-degree side to the 60-degree side, I would multiply by the square root of 3. Well, 4 times the square root of 3 times the square root of 3 is 4 times 3, which is 12, so that works great. And now I want the hypotenuse. So what I will do is the second thing I need to do here is I multiply the 30-degree leg by 2. So I'll come over here. I will multiply the 30-degree leg by 2. 4 times 2 is 8 times the square root of 3, right? So again, you can grab the Pythagorean theorem, multiply those out, and see if you get the same thing. Is that the exact same problem that was in our sheet there? It was the exact same problem. That's kind of a bummer. I was going to say that thing seemed familiar. So let's do this one instead. So if we look at number 6, we know that if we are given a 60-degree side, we're going to go over here. And the first thing to do, we're given a 60-degree leg, we're going to solve for the 30-degree leg by dividing it by the square root of 3. So I'm going to go over here and I'm going to divide 8 by the square root of 3. So 8 divided by the square root of 3 is going to be 8 times the square root of 3 over 3. That'll be my 30-degree side. 8 times the square root of 3 over 3. I don't need to simplify this anymore. If this was like 8 and 4, I would simplify it, or 9 and 3 I would, but 8 and 3 I'm not going to simplify. And now finally, to finish this off, we're going to solve the hypotenuse by multiplying the 30-degree leg by 2. So I'll go over here, and I'll just multiply 8 times 2 is 16. 16 times the square root of 3 over 3. It's that simple. I don't need to do more than that. And then finally, what happens if they give us a problem like number 8, where they give us the hypotenuse? So I'll go back over here. If they give us a hypotenuse, so here, they give us the hypotenuse. The first thing we're going to do is solve the 30-degree leg by dividing the hypotenuse by 2. So if I divide, and again, this is the 30 degree, so if I divide 6 by 2, I get 3. And then I will finish it up by saying if I want to solve the 60-degree leg, I multiply the 30-degree leg by the square root of 3. So I'm going to get 3 times the square root of 3. And again, if I take 3 squared and I add that to 3 times the square root of 3 squared, I should equal 6 squared. 9 plus 9 times 3 is 27 equals 36. So some really cool math going on there. Here we have some word problems. So an equilateral triangle has side lengths of 10. Find the length of the triangle altitude. Just so you know, this would be the altitude right there. I'm pretty sure. Let me pause that and make sure that altitude is a line segment through a vertex and perpendicular to the other side. So if you look over here, you can see that I would get that right angle. So it goes from the vertex here and it makes a right triangle. And then on this one, they're saying the altitude is 18. So can you find the side length? So that is the 30, 60, 90s in a nutshell. A little bit tricky, but not too bad. Especially, again, I know this looks like crap, and hopefully your handwriting is a lot better, but you can see if you're given one side what you need to do, if you're given another side what you need to do, and the 30, 60, 90 have 3 different sides, the 45s only have 2 because the legs are the same. And if you just follow these patterns, you'll eventually not need to look at the graphic organizer anymore, I think. If you do need to look at it, who cares?